All right, we were ready for the third piece. What we've done so far is we started out and we didn't have significance. These are not significantly different. We don't have enough evidence to think that there's any difference in the population. We shifted and went to a different variable. We created this new variable, attractiveness, and made that the response variable. Looked at that and said, oh yeah, these differences look more pronounced. Looked at the mosaic plot and oh yeah, these seems like they were kind of different. Went over to do the chi-square test and we had a p-value less than 0.05. It's 0.001. And so we said, all right, we're going to do a pairwise comparison. What we're going to do is see if that significant difference is coming from a difference between neither and eyeglasses, or maybe it's a difference between neither and both categories, or maybe it's between neither and contact lenses, or maybe it's between eyeglasses and both, or eyeglasses and contact lenses, or maybe it's between both and contact lenses. And what I've just done is out of these four categories, I've paired them up in all the different ways they can be paired up. First category with the second, the first with the third, the first with the fourth. Now the first has been paired up with all three of the other categories. You don't want to pair it with itself. It's definitely not different from itself. So I did first with second, first with third, and first with fourth. But then I need to do second with third. I already did second with first, but I haven't done second with third and second with fourth. And finally, I need to do third with fourth. So there's one, two, sorry, let me do that over again. One with two, one with three, one with four, two with three, two with four, and finally three with four. So I have 6 different pairs that I need to check to see which ones of those differences are significant. And so there's a couple of things that I have to set up before I do that. The first one is to be really clear in my mind what those combos are. Right? So I laid those out here and I was very explicit into what I was considering category 1 and category 2 and category 3 and category 4. I was using this plot here to go neither eyeglasses, both contact lenses, just like it shows up here. Neither eyeglasses, both contact lenses. And then I said, okay, since there's 6 different pairings, my adjusted alpha, so I'm not going to compare my p-values anymore for this Bonferroni post hoc test. I'm not going to compare it to 0.05. I'm going to compare it to 0.05 divided by 6. Whatever this is, how many pairings you're actually going to work with, that's what you divide your original alpha by to get what's called your adjusted alpha. So in my case here, 0.05 divided by 6 is 0.0083. So now the p-values that I'm going to get when I run my Python, I'm going to see if they're smaller than 0.0083. Okay, that's kind of the first step. Second step is the code that Python needs is these 4 lines. And this is just the name of this little thing in those curly braces. But then I am going to use that thing that I just set up in this line and create kind of a variable out of it, a df variable out of it. And then I'm going to make a table using that variable together with my response variable. And then finally do the chi-squared using that table. And so what you'll notice that I've done to kind of keep myself sane is I use the numbers of the categories that I'm comparing. So I'm starting with category 1 versus category 2. And then the next time I'm going to do category 1 with category 3. And the next time I'm going to do category 1 with category 4. I'm going kind of in order, the same way I laid these out. And as I name these names and use these names, I'm putting the 2 categories, the numbers of the 2 categories, right at the end of the name. So since I'm doing 1 with 2, I put 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, and finally 1, 2. All these different places are saying, hey, right now I'm comparing 1 with 2. So this is my explanatory variable, goes right there. This is my response variable, goes right there. And this one, you're putting the exact way that you formatted. Oops, and I just moved my R. Oopsies, let me move it back. There we go. Neither is what this category is called. It has to, just like everything in Python, it has to be spelled exactly that way, lowercase n, all of that, right? But that's what I'm putting here. Neither, neither, compared with eyeglass, eyeglass. Okay, so this you set up, you number everything right, run this, and what it does is it says, okay, I got a p-value, just comparing those two, I got a p-value of 0.0006, which is less than 0.008. This has 1, 2, 3, 4 decimal places. The 6 is in the 4th decimal place. And so if I go to 4 decimal places on this guy, 0.0083, this is 0.0006. So this is definitely less than that. Okay, I have significance. And so that's why I wrote this sort of heading. 1 neither and 2 eyeglasses have significantly different proportions of attractive. So that's kind of, I wrote this after I ran it. I saw whether I had significance or not, and then I adjusted what I said here and ran it again so that the top thing looks like it looks. Then I did it for 1 versus 3. I went through and did 1, 3, 1, 3, neither, both. Okay, neither, both. Okay, neither, both. 1, 3, 1, 3. Adjusted all that, ran it. And this time I have a huge p-value. So I put in, no. These two do not have significantly different proportions of attractive. So they may be a little bit different, but they're not different enough to suggest that they're different in the population. So these category 1 with category 2, these are significantly different. But category 1 with category 3, nope. They may not be perfectly equal, but they're not different enough to give evidence to think that it's different in the population. Okay, so I've done this with this and this with this. These are significant, these are not. Keep going, and I do that for all 6 of these. 1 with 4 did not have a significant different proportion of attractive. And here's where you start to go, well, wait a minute. These are about the same. If these are different from these, how come these aren't different from these? Well, it's because this is such a small sample. That's why. So when I look down here, my p-value is pretty small. 1 with 4, my p-value is 0.0864, as opposed to up here was 0.65. Oh my God, it was huge, right? So this is small, but it's not small enough. It isn't underneath that 0.0083. So it's rare, but not rare enough. So nope, don't have significance. The next one, when I put 2 with 3, my p-value is 0.0017. That's less than 0.0083, right? So okay, these two are significantly different. And they look like they are, and they are. That was 2 with 3. 2 with 4, nah. Too big of a huge p-value, nothing. No evidence there at all. And then this one's a small p-value, but it's not small enough. It's just 0.065. Okay, so again, the cutoff isn't 0.05 anymore, where you're using this adjusted alpha, and every one of these pairs that had a p-value that was less than our adjusted alpha, I put over here on my slide, showing that they have a significant difference. All right, that's it. That's the Bonferroni post hoc test, where you pairwise compare and figure out where is that significance that you found out overall, where is that coming from? All right, see you in class.